This equipment is the servo hydraulic shake table procured under TechUp 3. The cost of the equipment is 53.1 lakhs. This equipment consists of a shake table platform, servo hydraulic actuator, servo hydraulic power pack, and the control system. The accelerations recorded during the past earthquakes are stored in the control system. Structural systems can be cast and placed over this shake table, subjected to earthquake motions, and checked for its stability.
The equipment can be operated both manually and servo controlled. In the manual mode, the air oil motor, filter motor, and hydraulic motor can be operated individually without switching on the computer. In servo control mode, by switching on the computer, the operations of the motors are taken care automatically. The oil is the coolant in the operation of the power pack. When the temperature of oil exceeds 45 degrees, the cooler fan starts by itself and cools the hot oil. When the oil level falls in the power pack, the indication can be observed on the control unit. There are several different techniques that can be used to test the response of structures to verify the seismic performance, one of which is the use of an earthquake shaking table. This is the device for shaking scaled structural models or building components with a wide range of simulated ground motions, including reproductions of recorded earthquakes' time histories. The Bhuj earthquake that had occurred in Gujarat on 26 January 2001 had a moment magnitude scale of 7.7 lasting for 110 seconds. Kobe earthquake or the Great Hanshin earthquake occurred in Japan on 17 January 1995 with a magnitude of 6.9 on the moment magnitude scale. It lasted for 20 seconds. El Centro had occurred during May 1940. The time history data file and accelerations recorded for these earthquakes are stored in the computer of the control unit. The shake table can be subjected to the displacement corresponding to the acceleration of the recorded earthquakes. The value of acceleration g, the amplitude of the earthquake, and the number of cycles are to be given as input. For any input given, the displacement is given to the table simulating the velocity and acceleration of the earthquake. The shake table comes to a stop after repetition of the number of cycles given in the input. As the shake table tests the resistance of structures during earthquake, it helps to understand the dynamic structural behavior which would be helpful to minimize the destruction. Earthquake shaking tables are used extensively in seismic research as they provide the means to excite structures in such a way that they are subjected to conditions representative of true earthquake ground motions. Various types of ground motions and seismic research can be done by using the shake table. Procurement of shake table under TechUp 3 will definitely enhance the research in the area of seismic investigations. 2 PhD scholars have opted to carry out research on seismic resistant structures using the shake table.